Alright, trigonometry. So this is one of the harder topics in FP1, or one of the topics that you or my year 12 class have found harder. Hopefully this is one topic also that will get easier the more maths you, or the more trigonometry you do in core. We're going to look at some common values of trig, sine, cos, and tan for, well, we'll look at that soon. Then we'll look at general solutions for cos, sine, and tan. And then at the end, finally, we'll look at some harder questions. Okay, so first of all, what do we need? So we need to know, well, it helps if you know. If you don't know these off by heart, we want to be able to work them out. You're not really tested on these. Yes, I don't think it's in C1, but really you should be able to get these values of sine, cos, and tan without a calculator. These are the common values. Actually, we also need to know what these are in radians. Now, remember when doing this that 180 degrees is equal to pi. So if you're converting any degrees to pi, to radians, it's as simple as you divide by 180. So let's say I had 27 degrees and I wanted to convert it to radians. I just do 27 divided by 180 and I times it by pi. And that'll give me how many radians it is. So each of these, of course, so that's, in terms of radians, that's 0. This is pi over 6. This is pi over 4. Pi over 3. Notice, we usually do it in terms of pi radians. Sometimes you do see radians as decimals, but in that case, what's the point of using radians? Why not just use degrees? Usually we want to use, well, there are points to using it, but usually we want to use pi, or we often do. Anyway, this is pi over 2, this is pi, and this is 2 pi. So what I said earlier about pi being 180, you could also remember 2 pi all the way around is 360. Now we want to know sine, cos, and tan of these. There are two ways of, well, there's one way of doing this is to remember two triangles. And give you some of the key values, not all of them, but some of the key values. So one of the triangles you want to remember is, actually let's draw a triangle. It's an equilateral triangle of side length 2. So I say, so this is going to be, this side is going to be 2, 2, 2, and then you cut it in half. So let's cut this triangle in half. And then, of course, therefore, this side is of length 1. And this side is, we're using Pythagoras. This is 2 squared minus 1 squared. It can give me this. So 2 squared is 4, minus 1 is 3. So this side is root 3. Now we can ignore this side. Ignore this. Now, as it was an equilateral triangle, this angle was 60 degrees. And because we cut it in half, this was originally 60. Now this is 30. And now we can just use SOHCAHTOA to work out. So we don't need, ignore this half. So all we really need. So I think, let's cover it up. All we need now is that triangle there. We don't need these values of 2 anymore. So really we want the triangle that's 1 root 3, 2. We don't want this stuff. Let's just get rid of that. Okay, so from this we can work out sine, cos, and tan of, well, sine, cos, and tan of 60 and 30. So let's work some of these out. Let's start from 60. So sine of 60, no, sorry, 30. So sine of 30, remember sine is opposite over hypotenuse. So what I'm doing, rule 30, this is the opposite, this is the hypotenuse. So sine of 30 is half. Cos of 30 is adjacent over hypotenuse, so it's root 3 over 2. And tan of 30 is opposite over adjacent, so we're just using SOHCAHTOA. Tan is opposite over adjacent. By the way, this video is going to be a little bit longer, so please don't feel like you have to watch all of it in one go. Just watch bits and then pause and come back to it. So tan of 30 is opposite over adjacent, so it's 1 over root 3. Okay, let's just okay, and we can work out these values for cos. And so we can fill these in as well. So 30 we worked out sine, cos, and tan, so it's a half. Let's plug these in, and I'll put them in green. Actually, no, green might be hard to see for some of you. Doing blue, purple. I like purple. Okay, so 30, sine of 30 is half. Cos of 30 is root 3 over 2. And tan of 30 is 1 over root 3, which you can, of course, you can rationalize that. That'll be just root 3 over 3. Doesn't matter how you write it right now. Often you probably see it as root 3 over 3. Okay, so done with 30. Let's deal with 60. You can do the same thing with 60. I'm going to speed up a little bit now. So now I just work out here. So sine of 60, opposite over hypotenuse, root 3 over 2. Cos of 60, adjacent over hypotenuse is half, and tan of 60 is opposite. Now this is opposite over adjacent, which is just root 3. Let's fill these in. So we've got sine of 60, what do you say? It's root 3 over 2. Notice you should notice there is this kind of symmetry here with 30 degrees and root 3 over 2. Cos of 60 is a half, and tan of 60 is root 3. Alright, so that gives us some of the values. Now we need another triangle. So this is a triangle, or equilateral triangle of side length 2. You cut it in half, you get 30 and 60 degrees. Okay, let's get rid of all this. Now there's another triangle that will give you the values for 45 degrees. It does give you everything, and really the best way I would actually, it's nice to know these are often in textbooks and it's nice to understand this stuff, but you don't need to, there are quicker ways of doing this, and I think those of you in my class, you've already seen it, and that's what I want to show you next. Anyway, what's the other triangle? So the other triangle is an equilateral triangle of sides length 1, if I remember. Yeah, so it's an equilateral right angle triangle of where two of the sides are of length 1. So I'm going to draw it like this. So this one's not as neat as before. Can't be bothered anymore. So this is going to be 90 degrees. That's going to be 1, 1. Obviously that's 45 degrees. That's for the same thing as that. And this is going to be, using Pythagoras, 1 squared plus 1 squared. So 1 plus 1 is 2, so this is root 2. And clearly from this you can just see you can work out sine, cos, and tan of 45. So sine of 45. Doesn't matter which angle you use. They're both 45. These are both 1. So adjacent, or it doesn't really matter if you use adjacent or opposite. So sine is 1 over root 2. Same as cos of 45 is 1 over root 2. Often you'd actually see these rationalized as root 2 over 2. Your calculator will give you root 2 over 2, I think. And same thing with these. Doesn't matter if you rationalize it right now. It doesn't really serve any purposes right now. Although if you later on it might. And tan of 45 is just 1. It's just 1 over 1. Alright, so we've got these other values. And I'll use the rationalized value for now. Although, actually, I didn't before, so I won't now. So it's 1 over root 2. No, let's use 1 over root 2. 1 over root 2. 1 over root 2. And 1. Now, of 0, well, none of these triangles gave me 0. But 0 is one you should remember from the graph. So sine of 0, remember, sine starts at 0. Cos starts at 1. Tan starts at 0. Also, tan, remember, an identity we can use. Tan of theta is equal to sine of theta over cos of theta. This is an important one. You need to know this for FP1. You don't need to know as much, I think, in core until your second year, but in first year you do. And 90 degrees, again, one you should kind of remember from your... none of these two triangles didn't give us 90 or 180 or 360. So 90 you should remember from your diagram as well. So if you drew a sine curve, remember that goes like that. At 90 degrees, it's at 1. Cos is at 0. Tan is at 90. Tan is undefined. Right, we're going to leave it blank. Remember, and it also makes it, we can't do 1 divided by 0, can we? All of these, by the way, you could have got this divided by this gives you this. This divided by this gives you this. This divided by this gives you this. All right, at 180, sine is 0. Cos is minus 1. Again, I'm doing it from these graphs. So sine 0, 180, 360. And cos, so this is my sine curve. And cos, remember, cos is like this. 180 is here. Of course, everything else is obviously from there. All right, so tan, of course, tan of pi, or 180. So sine was, notice sine is 0 at 180, cos is minus 1. So tan is 0, 0 minus 1 is still 0. And of 360, of course, so this is, sine is 0, cos is 1, tan is, again, 0. Okay, so that was quite long-winded, and that was, and this is, you probably do see this usually in core. This is covered normally, and it is useful to know. Well, it's just another. It's nice to know these triangles. They're not, but they're quite pleasant. Okay, so quickly, if you don't want to have to bother doing that, you want to remember all these values, or most of these values. If you want to be able to get to them, what we do is, if you remember, we do the numbers 0 to 4. So 0, 1, 2, 3, 4, and then 4. Also, if you look at these, there is a symmetry here. Ignore these last ones. for these ones, there is a symmetry. 0, 1, 1 over half, 1 over root 3, no, 1 over 2. What is this? 1 over root 2, root 3 over 2, 1, again 1, root 3 over 2. If you look at these, there's a symmetry. So we're going to use 0 to 4, 4 to 0, 3, 2, 1, 0. Okay, so this whole process, what we're going to do, and then the next thing we need to do, so there are two things we just need to do. We need to either we divide and then we divide and we square root. So what do we do? Which order? Well, you can always figure out by if I square root this, I'll get 2, and then I divide it by 2, I get 1, which is what I want. So you square root. So your next step, again, if you forget which order, you can just, because you should know some of these values. So you square root everything. And then you divide by 2. Square root, divide by 2. And what's the point of doing all this? Well, these are my values for sine. Of course, remember, sine starts from 0, so this is 1 for sine. Cos, don't get these mixed up. I haven't done bother with tan, but remember, tan is just, I can get tan easily just by doing this divided by this. And these, what angles are these for? These are important ones that we need to know. So it's 0, 30, 45, 60, and 90. Okay, so these are actually things that in the new GCSE you need to know. So year 12, and if you don't think you need to, if you don't want to know these off by heart, you really should learn them because your year underneath you know these off by heart. And then we can simplify this because this is just 0. This is just 1 over 2. 0, 1 over 2. This one, root 2 over 2, is exactly the same as 1 over root 2. Root 3 over 2, notice the same. And this is root of 4 is 2. 2 over 2 is 1. Of course, that's simplified. This is 0. This is 1 over 2. This is root 2 over 2. Root 3 over 2. And this is 1. Exactly the same as that. Okay. Moving on. All right, so now we're going to do something a little bit different and something that I haven't done in class, but you're going to find so we're going to find these exact values. Now, before we even get to this, I'm going to just, you can ignore this for now. I want to define, forget everything you know about trigonometry for now. I want to redefine what sine and cos are. So this is going to be something that you may not have seen before, although sometimes you see this in core. It's going to be useful for you in terms of understanding trigonometry. Okay, so I say okay so a lot, don't I? Oh, I'm not going to stop. I like it. All right. Okay, so we start off with a circle, a unit circle, so a circle of radius 1. Let's do it in red. Oh no, don't want it filled. So empty circle outlined in red. So this is a unit circle. So this is a unit circle. So it's a circle. Think of this as a circle of radius 1. That's what a unit circle is. Centered on the origin. And let's send this to behind. So let's see if I can do this with my pen. So apology. You can, of course, speed it up at some points. There. Okay. So this is a circle of radius 1. Now, what's the whole point? What am I doing? So 1, 1. There's a 1 there. Don't worry, there is a point to this. It will be worth it in the end if you get what I'm going to do. So minus 1, obviously minus 1. So we don't know what sine and cos are. So I'm going to define sine and cos from this circle. I'm going to say, imagine just that I take any angle from here. So make any angle, and I draw the line for that angle. So by the way, we measure angles. We always measure angles from the positive x-axis, and we draw a line like that for that angle that I picked. So let's call this is going to be any angle. So this is going to work for any angle. So I'm just going to call it theta. And then I am going to define sine theta to be the x coordinate for this given theta. I'm going to define y to be the y. I'm going to define cos theta to be the y coordinate. So let's draw. So I'm going to use connectors here. Let's do a dotted. That is a bit thick. That is my x. So by definition, you can think of this x value that I've got here is my cos theta. And this y value that I have here is my sine theta. So this is my definition. So how does this help us? So sine theta equals x in this circle. Cos theta, by the way, this is, I'm not just making that. You will, if you look for the unit circle online and trigonometry from the unit circle, you can find more of this. Sorry, sine theta is y. Cos theta equals x. So what does this mean? Well, essentially what I'm saying is when I pick any angle, the value, the coordinate I get, my x value is what sine theta is. My y value, I keep on saying it the wrong way around, sorry. So when I make any angle, so that angle, let's say I pick another angle over here, then my x value that I get, so let's say I do a dot line there, my x value is cos theta. My y value is sine theta. That's what sine theta is. That's how I'm defining it. So what can we see from this? Well, clearly, cos and sine have a maximum, each of them have a maximum value of 1 and a minimum value of -1. Let's work out some values from this. So I'm going to get rid of this for now. So let's just, actually, let's look at this. So from this, we can say what cos of 0 is. Just imagine, just imagine what cos of 0 means I'm making an angle of 0 degrees. So that means that's a straight line. So what's my x coordinate? Remember, cos theta is your x coordinate. So that's just simply 1. What is sine of 0? Sine of 0. That's a 0, not a theta. Well, sine of 0, when I make an angle of 0 degrees, so imagine it's not this line anymore. It's imagine just this 0 degrees there. Well, that's my sine is my y value. What's my y value there? Well, it's 0. Let's use some other common ones. Let's use 90 degrees. Again, I can use pi, or I can use radian. So that'll be pi over 2 pi, 3 pi over 2, 2 pi again. Or usually we would say, often we'll say 0 pi over 2 pi, 0 minus pi over 2 minus pi. Okay, let's still use degrees for now. Let's do sine and cos of 90 degrees. Now again, you may say, I already know what these are. What's the point of doing this? We'll see the point later. Well, let's work out. When I make 90 degrees, so imagine. So actually, let's get rid of this line. Oh, actually, let's rotate this line. So imagine now I'm making an angle of 90 degrees. Ignore the dotted line. Ignore that dotted line, because the dotted line doesn't really work anymore. How can I get rid of this? All right, so now I've made an angle of 90 degrees. So let's just look at the blue line. Okay, so that's my 90 degrees. So what's my sine, what's my cos of 90? Well, remember, I said sine of 90, sine is my y. So what's my y here? Well, it's just 1. What's cos is my x. So it's just simply 0. Let's do a different one. Let's pick a different angle. Let's pick 180. Let's do cos of 180, sine of 180. Well, now, so I'm making an angle of 180. So my line, and I'll do this in, let's say we'll do this in bright pink, and we'll do a thick line. So now 180 is there. That's my angle of 180. Ignore that now. That's 180. What's my sine? What's my cos? Well, clearly my sine, well, let's just do cos first. Cos, I said cos is my x, so that's -1. Sine is my y, so that's just 0. And you can do other values like that. Of course, you can get tan, but tan is just sine over cos. And we can also find for other bigger angles now as well. By the way, the whole point of this is, if you just did triangles, how on earth did you find sine and cos of 180 degrees from a triangle? Triangles don't have an angle of 180 degrees. How did you find them? Well, you have to do all kinds of things like making up a acute angle from that kind of thing. It's a bit messy. This way is a little bit better. So let's do big angle. Let's do 720. Cos, hopefully by now you've got a little bit, and sine of 270. That's an n. Also, by the way, this is also can be called -90 degrees, -90 degrees if you go clockwise from there. Well, now we're all the way up to here, 270 degrees. So it's lying there. So when I join, we're also talking about in all these examples, we're thinking about making that angle and then joining up to my circle. Right. So now it's that red line here. 270 degrees. So what's my sine, what's my cos? Well, clearly, cos is my x. Just look horizontally. 0. Sine is my y. It's minus 1. Okay. So what's the whole point of this? Well, one more thing before we go there. So how does this relate to, you already know things like SOHCAHTOA and sine. Well, how can we relate that to, well, all those things that we know from before? Well, we can extend this circle. So let's just take this for now. And let's use our general line for angle theta. And so ignore the blue line. I can't get rid of it for some reason. I don't know how to. I should be able to select it and get rid of it. Yes, the blue line. Okay, so don't need that anymore. So again, let's just pick any, let's say general angle in the unit circle. So any theta. So this is now theta. It's not fixed angle. And so, and of course we knew, and I'm going to do this dotted line. That's my x. That's my y. And that is a unit circle. So that's length of 1, remember. And it's theta. Okay, you may say, okay, how does, let's extend this now. Let's not say it's not radius 1, because you always get a hypotenuse 1, because, oh, so remember, if you were just using SOHCAHTOA, that doesn't make sense. This doesn't make sense. Sine of theta is adjacent over hypotenuse. So adjacent, so x will be sine theta. Oh, sorry, x will be cos theta, as it's adjacent. It's cos theta times hypotenuse. Y is sine theta times hypotenuse, so it's just sine theta. Now, let's make our, we won't always have a hypotenuse of 1, so let's extend this. Let's make that longer. Let's give it any hypotenuse. Same angle though, notice same angle. My theta doesn't change. Same angle. I made a huge angle. And so now so this length is now going to be, and let's pick for all the way up to this. So that length is h. Let's finish the right angle triangle. Still for the same angle though, and this is my opposite. No, this is my adjacent. So I'm just going to call it ADJ, and this is my opposite. Well, let's see if we can do it. So what do I know? For example, our origin, I know sine of theta is equal to x, right? That was the definition. I rubbed it out, but sine theta, I do it again every single time. Sorry. Cos theta is equal to x. Sine theta is equal to y. I've made that mistake so many times. Just remember, cos theta is your x, sine theta is your y. All right, this time that is correct. Okay, this is the correct form. If I've said it, if I've made any mistakes in the example, I apologize. Cos theta equals x, sine theta equals y. So I know cos theta in this particular example, cos theta is equal to x, right? Definition. And this is true for whatever angle that was. It's still going to be, that's just one definition. I'm going to write x slightly different. I'm going to write it as x over 1. Well, what is x over 1 exactly the same as? Well, these two, look at these two triangles, right? Look at that small triangle in the circle, this triangle, and then this bigger triangle. Well, I haven't completed the triangle yet, but you can use your imagination. Actually, let's just complete that triangle. Look at the small and the big triangle. Well, they're similar triangles, aren't they? Because you've got the same angle here, and then this side and this side are just extensions. They're similar triangles. It's a circle in a circle. It's a triangle in a triangle. Similar triangle. Because both of them have 90 degrees. Theta, that's a shared angle, and obviously so that angle must be the same. So these two, this triangle here and this big triangle, are similar triangles. So I know cos theta equals x over 1, but because of similar triangles, if that side divided by that side, that's also in my small triangle, which is this, if you don't see it, it's exactly the same as this whole big side divided by that whole big side. So that's equal to adjacent over hypotenuse. Well, isn't that my ka? And similarly, you can find from this my sine, cos theta, sine theta. Remember, sine theta is y. Good, I got it correct. So, but I'm going to write it as y over 1. But using similar triangles, that's also equal to this side over this side. So opposite over hypotenuse. So you may say, oh, what's the point? I already knew this. Well, we didn't know this because we didn't define this. We defined it from the circle. We started off from a unit circle, cos theta equals x, sine theta equals y. And now we've seen, okay, we can actually extend this. And you can do this with tan as well, but tan is a little bit messier. You have to draw tan. It's not as obvious. So we know these things, so we can actually use them. So what's the whole point of this? You may say, oh, this brilliant. Hopefully some of you found it interesting. But what's the whole point of doing this? Well, it will help you. From now on, I'm going to use circles. Instead of using diagrams, I'm going to be using circles. What's the great thing about these circles, of course, the periodicity is obvious. It's obvious that it repeats every 360 degrees because by my value of x, my value of y, 360 degrees, I get the same value of x, same value of y. Every 360 degrees, I get, and so on. Similarly, but not only that, I will get the same value for my x. I'll also get, for negative theta, I'll get the same value of x. So cos theta is equal to cos of minus theta, and other things. Okay, so we're going to get rid of that for now. And we're going to think. Okay, so let's look at these examples now. So let's work out sine of 135. So sine of 135 degrees without a calculator. Well, let's use my circle here. So 135, where is it? Well, it's over here, isn't it? Well, it's exactly in between these because right, so excuse my poor penmanship. So sine of 45, let's just use a straight line there. So and that in there is 135 degrees. Well, how do I work this out without a calculator? Well, using symmetry, I know that first of that's going to be 45, obviously. So 180 minus 75. Using symmetry, I know that what I get here will be exactly the same as what I'd get for 45, but it's the negative. Now, as it's a sine, remember I'm working at sine. Remember, sine is your y. This, when I make 45 degrees, what I get for my y here will be exactly the same here. So sine of 135 is exactly the same as sine 45. Now, what is sine 45? Well, we already know how to work that out. We've already did that. We've already got a table for that. Sine of 45 is 1 over root 2. Again, or rationalize this as root 2 over 2. Again, what did I do? On my circle, I did 135 degrees, and I did that. Well, I don't know obtuse angles, but I do know acute angles. So essentially, I'm relating everything to angles in this quadrant. Now, essentially, some of you may, if you've done cast, you're saying this is actually very similar to what I'm doing cast. But because we understand what sine, cos, the unit circle, we don't need to use cast anymore. It gets in the way. If you don't know what cast is, don't worry about it. You don't need it. So what do? We did, well, sine of 135. Again, remember, sine of theta is my y value. So I'm actually looking for this y value here. So sine of theta, that's that y value I want. Well, I'll get exactly the same thing if I went to 45. So I know what sine of 45 is. Let's do something a little bit. Let's do part 2. Let's do cos of 240. I'm going to do a few more examples actually. Here. So cos of 240. So let's get rid of these. So where's 240 degrees? Well, 240 degrees is not there. 240 degrees is not there either. Let's rotate this. 240, so let's just say it's something like this. In fact, it'll be actually closer to 270, won't it? All right, let's say that's 240 degrees. All right, so what do I want? I remember cos theta is your x. So all I want is that x value there. So this whole angle here is 240 degrees. So what must that mean? So that bit there must be 180. So that's 180. So that must be 60. Now all I want is this x value because cos of theta is x. All I want, oh, okay, I got it right this time. I was going to think I'm saying it wrong. Cos of theta is x. So I want this x value. But just by using symmetry, I know, well, all that x value would be exactly the same as if I just went to 60 here. And work out the x value, but not exactly the same. This is the negative of that. So cos of 240 is the same as minus cos of 60. Now, what's cos of 60? Well, we already know what that is. Right? Cos of 60, look here, cos of 60 is a half. So cos of 240 is equal to minus a half. Right, I'm not going to do these ones just yet. Let's do actually a few more like this. So let's do, I'm not going to do 3 and 4. Let's just call this A. let's work out. So again, we're relating, the whole point of this is relating to things that are here that we already know. So let's work out sine of 225 degrees. Well, again, 225 is there, right? And that's 180, so that makes a and what do we want? When I'm working at sine, well, I can make this triangle here, and also I want the y value, don't I? But so that's, if this whole thing is not 224, but just 225. That whole thing is 225. That's 225. Take away 180. That's 45 degrees. So I want this sine value, which is the y. So I'm just going to work out the 45. And if I work out 45, it'll give me this one. And then using symmetry, I know that's just the negative of that. Now I know sine of 45. We already worked it out. It's root 2 over 2. So this is just simply, because it's over here, it's minus root 2 over 2. Or minus 1 over root 2. Doesn't matter how you write it. Let's do a different one. Let's do, I'll do tan soon enough, but let's say cos of, and in fact, we can even do negative angles. Let's do a negative angle. So let's say cos of minus, let's not do 60, we've already done 60 enough times. Let's do minus 30 degrees. Well, in fact, some of you should remember cos of minus 30 is exactly the same as cos of 30, isn't it? It's something we know, but we can actually look at it quite simply from our diagram. That's even obvious. So if you don't remember that cos is the same whether you use positive or negative, well, let's make minus angle means you're going clockwise from the x-axis. So that's 30 degrees. So it's minus 30 because it's going this way. Well, what do I want? I want the x value. I want this. Cos of theta is the x. Just look, when you're thinking cos, think horizontally. When thinking sine, think vertically. So, but that's exactly the same as if I went here and I did 30. And not only is it, and it's exactly the same value, because cos of 30 gives me a positive value. Cos of minus 30 will give me a positive value. So this is the same as cos 30, which I think is root 3 over 2. Let's do one more. Let's do, okay, notice this is much easier, I think. Once you get the hang of this is much easier than that method we used to use with all the diagrams. Because you just use a circle and just relating it is really easy. Again, we're relating it to these ones that we know. We're not going to be using other angles. So let's work out sine and cos of, let's say, 310. Okay, so let's ignore that. So where is that? So 310, so is over here. So that's something like that. Again, these are sketches, doesn't really matter. So that's 310 degrees there. Now, what do I want? Remember, I want the x value, because that's my cos theta, and the y value, because that's my sine theta. But one thing we're going to do, well, if that's 310, well, isn't that 60 there? Not 60, that's 50. Apologies, I shouldn't have done 310. 310 gives me one that, I should have done 300, my mistake. I should have done 300. Because 300, we can't get to 310 using any of our values that we know. So 300. So that should be a 0 there. So that's 60. So let's work out cos of 300 first, because it's the easier one. Well, cos of 300 is just, when I make that angle 300 degrees going anti-clockwise from my x-axis, it's my x value for this line. So it's this coordinate. Well, I know I'd get exactly the same coordinate, or same x value, if I did 60 degrees. So this is exactly the same as cos of 60, which we know is equal to a half. Let's now think about sine of 300. Oh, 300. Well, again, let's just think about this triangle. Notice I always make a little triangle of 60 degrees. I want this y value. But I know if I did sine of 60, notice this is my angle with 60, and I get the y value here, well, this one is just the negative of that one. Well, what was that one? Well, I think this is just minus sine of 60. So why is it minus sine of 60? Well, when I get sine of 60, I get that y value, and then I just do the negative to get this one. So what's that? Well, sine of 60 is root 3 over 2, so this is minus root 3 over 2. Notice how simple it is, right? Don't need to, just drawing the circle, much easier than drawing those curves, and it's easier than remembering all those possible formulas that you'll see in the book. Okay, let's go into the last two examples. I'm going to get rid of all this stuff. You'll see, by the way, I'm going to use this a lot in the next, I'm going to use this quite a bit. So I'm going to leave that there because cos, remember, cos is my x. Cos is my x, sine is my y. Don't need this stuff anymore there. Although, and this is a unit circle, so it goes from 1. Let's leave that there. So 1, 1, minus 1, minus 1. Okay, so we want to work out tan 11 pi over 6. So where is that, first of all? Let's find 11 pi over 6. What does that mean? Well, this is, if you think about 2 pi is the whole thing. If I add another pi over 6, I'll get to 2 pi, won't I? I'll get 12 pi over 6, which is 2 pi. So that just means it's a pi over 6 away from my whole circle. So 11 pi over 6. Also, you can think about it as this is, so I'm off by about that. Well, actually a little bit more than that, I'd say. Let's say that much. So 11 pi, where this whole angle here is 11 pi over 6. Notice we're using radians now, not using. So we want to work out tan of this. So there are different ways of doing this. We're gonna work this out by just saying it's sine over cos, right? So let's just say, by the way, you can use a count. It's sine over cos, sine theta over cos theta. In fact, I'll explain a slightly quicker way of doing this first. But let's work out sine and cos separately, and then we can work it out. There's a quick way. So we want, again, sine of theta. What is that theta, by the way? Well, sine 11 pi over 6. That should be the same thing. So 11 pi over 6. 11 pi over 6. So what is sine 11 pi over 6? Well, and what is cos 11 pi over 6? Well, let's do cos first. Remember, cos is your x. So if that's 11 pi over 6, that's pi over 6. I'll get the same x value if I went to pi over 6. Notice, I know it doesn't look the same, but imagine these angles are the same. So cos of 11 pi over 6, that's an 11, is exactly the same as cos of pi over 6. Now, pi over 6 is one of those ones you know. This is cos of 30 degrees. This one is, at the bottom, is root 3 over 2. What about sine pi over 6? Well, sine pi over 6 is this y value, sorry, sine 11 pi over 6, when I make 11 pi over 6, is the y value. But I could just go to pi over 6, find the y value there, and just take its negative. Well, so this just means that this is minus sine pi over 6. Well, I know what sine pi over 6 is. That's, by the way, that's 30 degrees. That's half. This is minus half. Now I can simply just work that out. So it's minus half divided by root 3 over 2. Now if you forget how to do this, you can just write it like this if you want to. So it's the same as minus half times 2 over root 3. Should be a 2 there. Apologies, not a 3. Notice I've flipped it. So that divided by root 3 over 2 is times by 2 over root 3. And then that's just minus 1 over root 3. Okay, now what's the quicker way? Well, how does it, maybe because you're thinking maybe I could relate it to, instead I could relate it to somehow, this is equal to some, it's almost or equal to something like pi over 6. So instead of going from sine and cos, can't we just relate 11 pi over 6 to pi over 6? Yes, we can. If I look at this, and if I look at tan pi over 6 is 1 over root 3, and I have 1 over root 3 here, but I have negative, so this is equal to the negative of this. Now, how could I have done that without doing sine and cos? How do I know that it's going to be negative here? And again, if you knew cast, well, you already know it, because by using cast, because you say, oh, here only cos is positive, here everything is positive, here sine is positive, here tan is positive. What you could do is just think about this. Tan is sine over cos. So, sine over cos. Sine is your x. No, sine is your y. Cos is your x. So sine over cos, well, in this here, sine and cos are both positive. So sine over cos is going to be positive, so tan is positive here. Same thing here. Well, here, sine is my y. In this quadrant, I'm thinking about this quadrant. cos is my x. They're both negative, so this side will give you something positive. So tan is positive here, positive here. Here will be negative, here will be negative, because over here, cos between 90 and 180, cos is negative, sine is positive, positive over negative is negative. And over here, between 270 and 300, cos is my x, cos is positive, sine is negative, negative over positive, because that's what tan is negative. So how does it relate? Well, I can just say tan of 11 pi over 6, which is all the way over here. Well, I'll just go to pi over 6. As always, I'll go to the acute angle. And it'll be equal to exactly the same thing, but because this is the negative, it'll be the negative of that. On the other hand, if I had this over here, where that was pi over 6, so if I was working out tan of, this would be 6 pi over 6, so 7 pi over 6. So that's another pi over 6 there. Well, that's exactly, because it's negative or negative, it'll still give you a positive value. So this is exactly the same as tan 11 pi over 6. Oh, sorry, this is exactly the same as tan pi over 6. These two give you the same value because they're both positive. We're just actually talking about one value. We're always using the acute values from here. These are both positive for tan. These are the negatives. So this one is just the negative of that. Okay, so that's quite a lot there we did there. So at this point, it might be just a good time to pause. I want to continue the video in a bit, but here you can pause and then come back to it, note what the time is, and then you come back to it later.